Okay, as I promised, here's a three-set Venn diagram, and we're going to do one of those. Now, for that problem, we're going to go forward into section 8I, and we're looking at problem number 3. So here's example 10, which comes right before that. It deals with juice, and you have 145 people surveyed, and they go through a step-by-step explanation of how to do that problem. And I'm going to do an example just like it from the book. This is problem number 1. You see, the explanation takes over 2 pages. So it's split up there. I'm going to do not 8I number 1, I'm going to do 8I number 3. Okay? Here's number 3. Okay. In a youth camp, let's zoom that in so we can see what's going on here. In a youth camp, each participant must take part in at least one of the following activities: chess, backgammon, or dominoes. You have a total of 55 in the camp, 25 participated in chess, 24 in backgammon, and all these other numbers. And then they ask all these questions, okay? Draw a Venn diagram to show the information. So that's what I'm going to do. So you'll want to have this in front of you while we do it, because I'm going to have the Venn diagram up, and I will have this in front of me as well. So we're going to take this information and put it into the Venn diagram. All right? Notice the order they give it in. First, they give all the ones that are in chess, backgammon, and dominoes. That's one big set. Then they give the double intersections. How many are in chess and backgammon? That's the intersection of 2 of them. How many are in backgammon and dominoes? That's another 2. And in dominoes and chess, that's another 2. And then they finish by saying there's 2 in all 3 events. This turns out to be a critical piece of information. We're going to start with that when we do our Venn diagram. So now let's switch to the 3 Venn diagram. Okay, and we're going to label this up. Let's see, let's make it bigger. We're going to label it in terms of chess, backgammon, and dominoes. So let's call this one chess, backgammon, and the third one will be dominoes, okay? All right. Now, let's see what we've got in terms of information. They tell us in the problem, in that one, they say they start off by, and I said the first thing we're going to put in is the triple intersection. How many of them do all 3 events? You know, that's where we start, okay? Because that's one region. Every other number they gave me is more than one region. When they gave me the chess number, that's all 4 of these regions put together. So I don't know how to divide it up. I have to do it one step at a time. And you'll see that in the example that comes before this too. So that's where we start, with the triple intersection. That's a region all on its own. So that's the only piece of information they gave me that goes in one region. Okay, now let's fill in some other ones. Let's read through it. The next thing it says is, if we go to the beginning, we have the number participating in chess, the number participating in dominoes, and the number participating in backgammon. I can't put those in yet, but the double intersections I can. So it says, all right, 15 are in chess and backgammon. So in chess and backgammon, there are 15, and I know where 2 of those are. So the total of this whole set, that looks like an almond-shaped thing, has to be 15. So that means there's 13 in that part of the set, okay? That means there are 13 people that play chess and backgammon but don't play dominoes, because there has to be 15 total, and 2 of them do play dominoes. So I filled that in. And in the book it shows you what I really did is I took the number and I took 2 away from it and then put the answer here. So you can tell that's the way we're going to do the next one too. The next piece of information in the problem says that 10 are in both backgammon and dominoes. So that means this set right here has to have 10 in it. I know where 2 of them are. That means there are 8 more unaccounted for, and I put them in here. So that was a total of 10 in that set and a total of 15 in this one. Now we're going to look at this set. The third subset, maybe I should be saying. There are 10 in backgammon and dominoes. I just took care of that. 5 in chess and dominoes. Well, that isn't 5 here. It's 5 in both of these. So 2 of them are here. That means 3 is here. Now there's 5 in here. So a very common mistake is to put the number they give you in that double intersection in this one. If they say there are 5 students that play chess and dominoes, I don't know whether they play backgammon or not unless I use that last piece of information. So that's how I fill that in. Now I'm not done. Now I have to go and fill in these regions, right? Okay, now we go back to the beginning. The beginning of the problem starts off by saying, there's 55 students in camp, 25 participate in chess. 25, well I don't have all 25 accounted for here. Here's 3, 2, and 13, so that's 13, 15, 18 of them. The rest of them must be out here. If I total it up to 25, I want 25 minus 18, so let's say 25. Let's say exactly what we did. We took away 13, we took away 2, we took away 3. We have the total we want it to be, and I took away each of these from it. And so I get 12 minus 2 minus, that's 7, okay? There are 7 chess players that don't play anything else. Let's erase that because it's distracting. All right, now they total up to 25. See, that's 25 total. In the whole chess board. I don't put 25 here. There's 25 total in there. Okay, next piece of information says 24, play back in. 24 will be where I start. And then I take away 13, 2, and 8. Okay? Well, I take away 13 from 24, that gives me 11. Take away 10 from 11, I get 1 backgammon player who doesn't play anything else. Okay? So now there's a total of 24 in here. 9, 10, 11, 24, all right? It involves some of the chess players, but this is all the backgammon players. Some of the backgammon players are chess players, some of them are dominoes players, and some don't play anything else. Okay, last one deals with the domino players. 30 play dominoes. There's 10, 11, 12, 13 of them. So I have 30 minus 13 down here. 30 minus 13 is 17, okay? So there are 17 players of dominoes that don't play any other of those events, okay? You might think we're almost done, but just like in the 2-circle Venn diagram now, I have to figure out if there's any out here. So I have to total them all up. Okay, let's total them all up. 7 and 13 is 20. There's 25. I can just start with the chess players, 25. And I don't want to count them again, so now I get 26, and 8's 34, and 17 is 34, and 17 is 51. All right? So that's 51. That means there's 55 total. That means there's 4 outside of all of them. Now I have a total of 55. Let's just check it. Let's total all the outside ones first. Here's 17, 18, 25, 28, 36, 49, 51, and 4 is 55. So that's all 55 of them, okay? All 55 of the camp participants. Okay, now we can go back and answer the questions, okay? How many of the participants are not taking part in at least one activity? Well, the answer to that is 4. These are the ones who are not taking part in at least one of the activities. All right, what else do they ask? How many are taking part in one activity only? All right, let's put up here. How many are doing one activity only? Well, these guys are only playing chess. These guys are only playing backgammon, and these are only playing dominoes. So it's those 3 I have to add up. So let's see, 17 and 1's 18. Add 7 to 18, you get 25. There are 25 of them that are only doing one thing. It just changes for each one of them. Okay. Now, what else? The next one asks, how many take part in exactly 2 activities? Okay. How many do exactly 2? Well, these are the 1 activity people. These are the 2 activity people, all 3 of these double intersections. That's the 3 activity people. That does not include. That's not included in the ones who only do 2 activities. So I take these and add them together. 3 and 8 is 11. 11 and 13, that's 24. 24 of them do exactly 1 activity. Okay, third question asks, how many do not take part in at least 2? Well, at least 2 is all of these, right? 2 or 3. How many do not take part in at least 2? That's the complement. So that's 1 or none. Okay? So I add all these together. 4, 11, 12, 29. 29 do not take part in at least 2. Now another thing I could do is add all these up and subtract from 55. So I could take 10, 13, 26 away from 55 and I'll also get 29. That's another way to do it. Works just as well. Okay, then we go to D. Problem D asks us about this one. How many take part in chess, given they take part in dominoes? Okay? So I'm starting with the ones that are in dominoes. If I look about the dominoes players, how many of them take part in chess? The answer is 3. And the language of that might seem a little strange, but we're building up to probability with our set theory that we're doing here. And we're going to do conditional probability. And that's a good example of the kind of set thinking that goes into conditional probability, which we'll get to later. So that whole idea of how many chess players do you have given that they're dominoes players, that's going to come back later. Okay. Last question here asks, how many of them take part in backgammon given they do not take part in dominoes? So if they're outside of the dominoes, how many take part in backgammon? These guys. All the ones that are outside of the domino circle, but inside backgammon. So that's 14. Okay? So, I need to take another look at D. I think I made a mistake there. It's okay for you to see me make a mistake. You might make mistakes too. The answer in the back said 5, so I need to take another look at that one. D says how many take part in chess given they take part in dominoes. Okay, so I found these. That's the ones I reported, but I forgot these. That's the mistake I made. So both of these are chess players that are inside the domino circle. So that's my mistake. That should be 5. It's 3 and 2. All right, so I'm going to leave that mistake in there for you to see. You can, I think you might make some mistakes too from time to time, so it's okay to see how you make mistakes, and then when you look it up, you find the answer, and you go back and say, oh, okay, that's where it came from. All right, so that concludes this exercise. Now we're going to go on and look at a little bit more complicated one that involves a variable next.